Hello and welcome back to my YouTube channel, Odavig Structure Hub. This is a place where you learn, build, and innovate. Today, I want to tackle the last example under stability of a dam. And this question is for CDAC student, is for Module 2 student, and any other student who is pursuing the course leading to civil engineering. So before I can begin, I want to encourage those who have not subscribed to this channel to do so and hit the notification bell so that you may be the first person to be notified when I upload a video. And if you find these videos relevant and educative, don't hesitate to share to your friends, to share to your classmates, comrades, or your fellow trainers so that they can learn with Odavig Structure Hub. So stay tuned as I start tackling the question up to the end. The question is on the board and it reads, a mass concrete shown below has a trapezoidal cross-section. The height above the foundation is 61.5 meters and its water face is vertical. The width at the top is 4.5 meters. Calculate the necessary minimum width of the dam at its bottom to ensure that no tension shall develop when water is stored up to 60 meters. Draw pressure diagram at the base of the dam for this condition and indicate the maximum pressure developed. Take density of concrete as 2400 kilogram per meter cubic and that of water as 1000 kilogram per meter cubic. So this is the dam made of concrete and this is the retained water. So before you can begin calculating the stability of this dam, the first thing to do is to indicate the forces exerted on the dam. So we have the first force, which is as a result of this pressure of the water. And if you can approximate, so let's assume it is acting at that point. So this is the force. So we call it F as a result of water pressure, and it is acting above h over 3 from the base. So this is small h. So it is acting at above h over 3, which is 60 over 3, like that. Again, the dam, it has a weight W acting at the COG of the dam. That is the center of gravity of the dam. So let's assume the weight of the dam, it is at that point. Like that. So this is the weight of the dam. We call it W. And we name this point N. Like that. And remember, also this is F. So that is F. This F and W produces resultant R. So it produces resultant R, which cuts at the base at point M, like that. So this is center of gravity. So we have this distance nm, you have distance nm, so this distance is x, and also you have another distance a, you have another distance am. So this is the distance am, which is distance d. Like that. So we have already indicated our forces acting on this dam, which is force F as a result of pressure of water, and we have the weight W as a result of mass concrete of this dam. And then we have the resultant R cutting at point M at the base. And then we have distance X, which is distance NM, and distance D, which is distance AM. So let's see how we can solve such a question. So allow me to clean here so that I can create more space for more calculation. So solution. The first thing to do is to calculate this force F. And you know that F is equal to unit weight of water times area of the dam times H bar, like that. So we know that the unit weight of water, we have been told to use 1,000 kilogram per meter cubic. So this is the density of water. So we'll convert density to unit weight by multiplying 1,000, this 1,000, with gravitation acceleration, which is 9.81. So let's proceed. Consider Consider 1 meter length of the dam. So which imply F is equal to the unit weight of water. As I said earlier, we take 1,000 times gravitational acceleration, which is 9.81. So we are converting from kilogram to Newton per meter cubic. Then times the area of the dam. The area is 60. Area is length times width, so we have 60 as the 60 times 1 meter length times 1 times h bar. H bar is 60 over 2. And then you punch your calculator to obtain the answer. So the answer is 17,658,000 Newton. So this is the force F. We now proceed to W. So W will be the weight of the concrete. Yes, the weight of the concrete, which is equal to unit weight of concrete times area of the dam area of the dam times length of the dam. So this is equal to the weight of concrete. We have been told to use a density of concrete as 2400 kilogram per meter cubic. So we will take 2400. So take 2400, which is in kilogram per meter cubic, multiply by 9.81. We are converting from kilogram per meter cubic to Newton per meter cubic. So from density to unit weight, then times the area. So area will be a half A plus B, the sum of two parallel sides. That is 4.5 plus B. We have not been given the value of B, of which we are looking for. And then times height. Height is 61.5. 61.5. Then times the length of the dam times 1. Again, you punch your calculator to obtain W. So the answer is 723,978 into bracket 4.5 plus B. Remember, our unit is Newton. So this is our W, weight of the dam. After calculating W, we now proceed to this distance X, which is distance NM. So let's see how we will calculate distance X. So NM, which is distance X, is equal to, we already know the formula is F over W times H over 3. H over 3, small h, which is the height of the water. So our F, this is our F, 17,658,000 over W is this one, 723,978, 4.5 plus B times H is 60 over 3. 60 over 3 is equal to X. So here 1, here 20. So let's punch our calculator and obtain the final expression. So the answer is equal to, X is equal to 488 over 4.5 plus B. So this one, you can round it or you can make it a whole number like that. After calculating distance X, again, another distance to calculate is distance AN. So distance AN, of which AN is given by this expression, A square plus AB plus B square over 3 into bracket A plus B. So A is our top width, which is 4.5, and B is our B, of which you have not been given. That is what you are looking for. So this one will be equal to AN is equal to 4.5 square plus 4.5 B AB, because this is B and this is 4.5. So 4.5 times B is 4.5 B. Then plus B square over 3 into bracket 4.5 plus B. Then we simplify the expression. So 4.5 square is equal to, let me do it on my calculator, 4.5 square so that is 19.8 equals to 19.8 plus 4.5 B plus B square over 3 times 4.5 is 3 times 4.5. That is 13.5 plus 3 B. So that is distance AN. After calculating distance AN, another distance to calculate is D. So D is equal to AN plus NM plus NM, which is distance X. So this one is equal to, so D is equal to, AN is 19.8 plus 4.5 B plus B square over 13.5 plus 3B plus distance X, which is 488 over 4.5 plus B, like that. Then we simplify the expression. So allow me to erase here. So you can simplify this D. So D is equal to 19.8 plus 4.5 B plus B square over, so let's factorize this. We will have 3 into bracket 4.5 plus B, like that. Then plus this one 488 over 4.5 plus B. So D is equal to, so the LCM is this one, 3 into bracket 4.5 plus B. So this one will go into this one. So we'll end up having 19.8 plus 4.5 B plus B square. And then this will go into this 3. So it will be 488 times 3. Like that. So D is equal to 19.8 plus, let's put like terms together, 3 times 488, that is, so the answer is 1464 plus 4.5b plus b square over 3 4.5 plus b. So 1464 plus 19.8 plus 19.8, so that is 14. So D is equal to 1483.8 plus 4.5 b plus b square over, let's open the bracket, so that is 13.5 plus 3b, like that. So that is our B. So let's check the stability of the dam. So for no tension to occur, we know that D must be less than or equal to 2 over 3B. So we want to relate this expression 2 over 3B to this, so that we can create an expression which will give us the value of B. So in other words, D is equal to 2 over 3B. So let's compare this and this. So we'll end up having 2 over 3B is equal to this, 1483.8 plus 4.5B plus B square over 13.5 plus 3B. After doing so, we will simplify the expression and form an equation which will give us the value of B. So this one is equal to, we will cross multiply, whereby 3B over, no, 2B over 3 is equal to 1483.8 plus 4.5B plus B square over 13.5 plus 3B. So we cross multiply. So we'll end up having 3 multiplied by 1483.8 plus 4.5B plus B square is equal to 2B into bracket 13.5 plus 3B. Then we open the bracket. So 1483.8 times 3, that is 44. 51.4 plus 3 times 4.5, that is 13.5B plus 3B square is equal to, you multiply, you open the bracket again, so that is 27B plus 6b square, like that. So let's put the like terms together. So we will end up having 6b square. We cross this to the other side, minus so we have 6b square minus 3b square, and then plus 27b minus 13.5b is equal to 4451.4. So that is 3b square plus 13.5b minus this one, it will cross to the other side, so it will change from positive to negative. 4451.4 is equal to 0. Then from there, you can either use the quadratic formula to solve the value of b, or you can use your calculator, scientific calculator, to solve the value of b. So for me, I want to use a calculator to solve the value of b. So therefore, the value of b is equal to, which imply b is equal to 36.34 meters. So ignore the negative part of the answer and take the positive, which is 36.34. So if you solve this using a quadratic formula or a calculator, you will end up getting 36.34 meters, and that is our B. So our B will be 36. Our B will be 36.34 meters, like that. So we proceed to the next question. So let's proceed to the next question. So part B of the question is asking to draw the pressure at the base of the dam. So pressure at the base of the dam, like that. So let's calculate the pressure at the base of the dam. So the maximum pressure so let pressure maximum at the base equals to W over B plus 6 W E over B square. So if you can take W over B outside, we'll end up having 1 plus 6 E over B. So this is our maximum pressure at the base of the dam. But we know that W is equal to, the expression we obtained for W was 72 39, 78 into bracket 4.5 plus B. So this was our expression for the weight W. So already we have our B, which is 36.34. So we can comfortably substitute this B with this value so that we can get the value of W. So this one is equal to 72, 39, 78 into bracket 4.5 plus 36.34. So let's obtain the value for W. So that is 4.5 plus 36.34 then times 72, 39, 78. So the answer is 2, 29, 5, 6, 7, 261.52 Newton. So that is our W. But we know that for no tension to occur, E is less or equal to B over 6, like that. So if we can remove this sign, we'll end up having E is equal to B over 6. So let's now replace E into this expression. So we'll end up having W over B into bracket 1 plus 6 times B over 6 over B. So B1, B1, 6, 1, 6, 1. So the final expression is equal to W over B plus, no, times 2. Because 1 plus 1 is equal to 2. So this one is equal to 2W over B, like that. So let me clear here. So we know that is equal to this now 2 W over B. So this one is equal to 2 times W, which is 29, 5, 67, 261.52 over B, which is 36.34, is equal to, you can punch your calculator to obtain the answer. So this is the maximum stress at the base of this dam, which is 1629,981 Newton per meter square. And the minimum stress is equal to 0 Newton per meter square. So if we can draw our diagram, pressure at the base of the dam, so this is how it will look like. So we'll draw up our pressure. So this 0 will be at point A, and this maximum will be at point B. So this is what will be our final diagram. So this is at A is 0. And at B is where we have our maximum stress, like that. So this is 0. And here, so this is the maximum stress. Like that. And the question ends there. So in my next lesson, I will start tackling retaining walls. So I want to just brief you what I will be talking about in my next session. So in my next lesson, as I have said, I will start talking about retaining walls. And in retaining walls, we will be able to know how to calculate the pressure exerted by the soil to the retained wall, which is given by WH square over WH square over 2 into bracket 1 minus sine theta over 1 plus sine theta. So this is given through Rankine's theory. So this is as a result of Rankine's theory of Earth's pressure. And this P will be acting at a height of h over 3 from the base. So in other words, if I can draw the retained soil so this is the soil and this is the retained wall. Retained wall. So this soil it exerts this pressure P. So this is P at a height of h over 3, like that. So we'll be calculating P using this formula, and this P is acting h over 3 at h over 3 from the base. Again, under retaining wall, we will be able to look at the intensity, pressure intensity at the bottom. So again, pressure intensity at the bottom, whereby the formula is given by P is equal to W over H into bracket 1 minus sine theta over 1 plus sine theta. So after that, we'll now start tackling examples. And these examples mostly will be coming from NEC past papers and CDAC past papers. And then after this, we'll also look at the surcharge retaining walls. Like that. So stay tuned, and if you have not subscribed to this channel, please do so and hit the notification bell so that you may be the first person to be notified when I upload a video. Like my videos, comment, and share to your friends. Also comment if you have any question. You can comment by asking your question, and I will be able to reply to your question. Thank you for your time. We meet again in my next session.